Assalamu alaikum. So, in part of this lecture, as I mentioned earlier, that we'll be continuing our organic chemistry chapter, where we'll be actually observing some examples of forming, you can say, the monomers of some of the polymers. Okay. Let's see the first example of today, which is amino acid, the tyrosine, can be synthesized from phenol. Okay. So that means our initial component will be what? Phenol. This is our initial component. This is given. This is how the structure is given by the examiner. So in the question, let's say this is the structure they've given. Now the reagents are, let's say, Cl, CH2, CHO, LCl3, anhydrous. So it gives us certain product which we need to find. This is, let's say, product A. From product A, through some reaction, let's say we get product B. Now, this means saying that from product B, there is another transition towards product C. Okay. From there, when we, let's say, add PCl5 with water, the first thing is PCl5, the second part is water, is given, we get certain product. Okay. Let's say this product as product D. Finally, when we add, let's say, NH3 in ethanol, and let's say high pressure, okay, we get this component. Okay, so see, they have given you just the initials or the starting component and the final component. Now it's your duty to find what should be the components A, B, C, and D. I would urge you to pause the video here and try it by yourself. So see, what's the first reaction happening? It's given AlCl3 in a anhydrous condition. That means what? Biddlecraft alkylation, isn't it? So from here, this molecule, the halogen will disappear, or the halogen will be eliminated. Okay, from this reagent, halogen will be eliminated. So we'll be left with the electrophile, which will be what? CH2, CHO, and there's the pass electrophile, isn't it? From there, we would get, consider here, in which of the benzene ring, like which carbon of the benzene ring is the like additional component here, or additional branches here. On the, let's say this is the carbon number 1, then 2, 3, 4, and carbon number 4, isn't it? So that means starting from here on to carbon number 4, 1, 2, 3, 4, which is here. So, and this structure is what? CH2, CHO. That means there is a CH2. This is the CH2 group, and we have another CHO, which could be written as yes. So this is our CHO group. Okay. Now from here, something is added, we get B. And from where something is added, we get C. And onto which, if something is added, we get D. Now we don't know what is B, We also don't know what is C, but we can assume what could be D. How? By back tracing. Okay, let's see what is the component, final component. Here we have what? After adding ammonia and ethanol, we get what? This, like something is happening here. We are getting, let's say, some like some amine here and carboxylic acid, and we don't know like in which product did we get carboxylic acid, okay, or in which product we get NH2 or something. But we know that, let's say, like adding PCl5 to, let's assume that this first, like over here, what is it? It is an aldehyde, isn't it? In an aldehyde, if we like, what could be further reaction for aldehyde? Let's assume, because we're seeing what? Phenol remains unchanged. So let's say that phenol remained unchanged throughout the whole reaction. That means phenol did not react in any of the steps. Let's assume that then this is the component, or this is the branch or part which reacted. See, here we have CH2. Here there is a CH and there is a COOH. That means additional 2 carbons has like appeared, isn't it? Here's one carbon, here is another, sorry, here's one carbon, and here is this another carbon. So 2 additional carbon appeared. Now that means we need 1 more carbon if we like try to observe. But before that, let's see what we have here. There's an aldehyde. Now from aldehyde, we don't know what is this, but if we assume what could be here, here could be an alcohol or a carboxylic acid. Now, how do I say that? No, I say that because, like in this case, when like in like the reagent PCl5 is added with only alcohol and carboxylic acid to do the transformation. Okay, so like let's say this is this product. Like we're just assuming, still not, and like we're not sure with anything. We're just trying to do some trial and error. So let's say this is the part, and like adding ammonia and ethanol does not give us carboxylic acid. That means carboxylic acid was somewhere in between, like between these 2 steps, B or C. That means in D we already have carboxylic acid present. Okay, now how do I say that? Because adding ammonia and ethanol does not give us carboxylic acid. That means carboxylic acid is there from before. Okay, if that's the case, then carboxylic acid remains, but amine, this could be produced due to like addition of ammonia. Now how can that be the case? See here, initially we have PCl5, and if there was like halogen, now in our halogen chapter we have learned, like from AS, you would see if you go back to the halogen of halogen alkane, you'd see that in the reaction of halogen alkane, if there's this halogen alkane there, when we add like ammonia in alcohol or ethanol, this halogen is substituted by NH2. So this is actually a nucleophilic substitution reaction, which is what? A characteristic reaction of halogen alkane. Let me just see if I'm correct or not. Yeah, alhamdulillah, so it's correct. So it's actually nucleophilic substitution. So far I'm guessing. I'm still not like I'm not seeing a mark scheme. I'm just trying to solve it with you. So I'm being neutral here. So this is how my like thinking process works. That's what I'm saying. So this will also come to you by like with like practicing. It's completely fine. Initially things will be tricky, but eventually inshallah you will get it. But like that's how it is, because adding ammonia does not give carboxylic acid. That means it is obvious carboxylic acid is there from before. That means this amine, this would have been like appeared from some halogen alkane. That means that's the only change. And that also makes sense because PCl5 was added. That means something changed here, becoming Cl. Now, what adding PCl5 to whom will give us this Cl? Now, as I mentioned, only 2 things reacted. One is carboxylic acid, another is what? Another is alcohol. So the other possibility is if there is the presence of this alcohol. If, let's say, if in this group, let's say for the simplicity, let's say we have here alcohol, okay, and we have COOH here. Then adding PCl5 would change this OH, displace this OH with Cl, okay. But you would ask then, why didn't this carboxylic acid reacted? Like, why did it remain same? Actually, the carboxylic acid itself reacted. Now, what happened then there? Actually, when this was the case, okay, when we added, let's say, PCl5, this happened. Sorry, yeah. So there they formed an acyl chloride, and here they form the halogen of chloride or halogen alkane. And from this halogen alkane and the acyl chloride, they also see added the second condition H2. That means they are doing hydrolysis. Now, this won't undergo hydrolysis reaction, but this acyl chloride will undergo hydrolysis reaction, regenerating our carboxylic acid. So our carboxylic acid is reproduced. So that's how carboxylic acid remained unchanged. Actually, it changed, but due to the addition of the second condition, it remained carboxylic acid. Okay. Now, let's see our let's see our then component B. So in component, like, then what could be our component B? From aldehyde to alcohol carboxylic acid. Now, if we do further oxidation of this aldehyde, we get what? Carboxylic acid. But that won't give us an alcohol, isn't it? But again, if we do, let's say, reduction reaction, it will give us what? An alcohol, isn't it? Reduction of aldehyde is what? Alcohol, because oxidation of alcohol with heat not under reflux give us aldehyde. That means going in the reverse process give us alcohol. Now, from alcohol, if we do oxidation, we get carboxylic acid. But again, there is this alcohol there. Then what can be done? The only reaction possible is now the adding of like cyanide, nitrile compound, okay? So that's the only thing remaining. Because if we add KCN with HCN, if we add those reactants, OH remains same here. Only the change would be there an alcohol will be generated and a cyanide will be generated. See, additional carbon came here. The third carbon appeared here. Now from here, when we do further, let's say, reduction or hydrolysis, carboxylic acid is generated. From there, this carboxylic acid, when PCl5 is added with water, alcohol displaced, like alcohol is replaced with chlorine and carboxylic acid remains what it was. Then further ethanol in ammonia and ethanol with high pressure gives us what? Replacing the chlorine gives us amine. So alkylamine. Got it? If you didn't get it, rewatch the video. Rewatch the video again and again. Trust me, things will be tricky. Rewatch the videos again and again and again and again. Like, observe what is happening. Then do it yourself. Again, if you get stuck, again watch the video. Try to understand in which part I said what I mentioned. Go back to the notes. Try to make sense. Okay, like, did I say everything correct or wrong? If I said anything wrong, then comment it down that yes, in this part I said something this, so that I can rectify myself, or I can at least in the description I can do the correction. So yes, and in that way you will be able to like do some active recall, and inshallah you'll be able to learn. Okay. Now, one thing here, you might say ammonia here, why didn't it react with our carboxylic acid? Because ammonia is what? Alkaline, carboxylic acid is what? Acidic. The reason is that's why ammonia is given in ethanol, okay, under ethanol. If ammonia was given under aqueous condition, then it would have reacted. Since ammonia is in ethanol, that's why it didn't react with carboxylic acid. Did you get it? Neutralization reaction didn't happen between carboxylic acid and ammonia. Why? Due to the presence of ethanol. But if ammonia was in presence of aqueous condition, that means ammonia, the solvent was water. then carboxylic acid would have been reacted. But the solvent is not water. The solvent is rather what? Ethanol is given. Okay, alcohol is in this case our solvent. Now moving on to the next part. Let me give us a certain elaboration what actually, let's say, happened in the like this from C to D. What happened from C to D? Like just for your understanding, when PCl5 is added, what happens? So when PCl5 is added, let's say this is our component. Okay, this is our acyl chloride when PCl5 was added. Now what happened? When we added a water with it, this is our water molecule. Okay, now water has what? Partial negative and partial positive charge, isn't it? Fine. Similarly, what will happen here is this carbon or this oxygen, like here, we have a chlorine in this place. This is our chlorine acyl chloride, since this is the acyl chloride. Over here, in the middle, here will be some heterolytic bond fission, okay? That will create what? Imbalance in like the number of electrons. That means here, a partial positive charge will be created. Hence, oxygen will become what? Partial negative charge, because here, like the bonded electron was taken by whom? Chlorine. So if that's the case, chlorine like separated. So chlorine got separated, okay? And one of the hydrogen from here also like it broke, it came out. If that's the situation, if that's what happened, remember this is the chlorine for another, like the alcohols part. This was like unchanged. This will remain unchanged, okay? This is after PCl5 added, and now we have added water in that situation. This was the carboxylic acid part where acyl chloride was formed. From there, we are in this such a situation here. Heterolytic bond fission is happening between carbon and chlorine, and hydrogen is also like being broken from water molecule. Then hydrogen will come here to form HCl here. No more charges remain, and this OH, okay, this will get attached with this part where we have Cl, and here we have, let's say, carbon and OH. So the instead of chlorine, this OH group appeared, okay? So that's how it was there, and we had this OH from before, which is the phenol, and that remained, okay? So that's how the PCl part actually reacted. Got it? Like that's how the hydrolysis of acyl chloride occurred in the second condition when the water was added. Okay, now let's see what type of reaction this final product can have. Let's say we have this final product in the previous reaction, which is this carboxylic acid is given, amine is given. From there, let's say we added some reagent, okay? In different conditions or in different situations, we added some reagents. In the first situation, we added sodium hydroxide aqueous. In the second situation, we added the HCl aqueous. And in our third condition, we added, let's say, Br2 aqueous. Okay, now it's your duty to actually try to find what could be the product. Okay, pause the video and try it by yourself. Now see, here we have added in the first part where sodium hydroxide. And we know sodium hydroxide reacts with whom? Reacts with acid, because this is basic. Now, which of the portion here is acidic? Obviously, carboxylic acid is acidic. But like amine is what? This is a alkylamine. Remember, this is not phenylamine, this is alkylamine. Why? Phenylamines, amine remains with whom? Bonds with direct benzene. If there was this NH2, then it would have been considered as what? Phenylamine. But since there is no like amine added with benzene ring directly, that means what? That's not phenylamine, that's just normal amine or alkylamine. From there, let's say that carboxylic acid will react. But is there anything else? Obviously, phenol. Phenol is acidic, isn't it? So that means our final product will be this will remain in H2. However, here we will have COO, Na. We can give the charges as well. O minus and Na plus, and here as well we have O minus Na plus. Okay, that's our sodium phenoxide part, and here we have sodium carboxylates part. Okay, like carboxylate ion and phenoxide ion. Like both are in together. We are having the structure, but they won't ask such complex names. Okay, no need to worry. Now let's see if HCl is added, what will happen? HCl is what? Acidic. Now obviously it won't react with carboxylic acid and phenol, but it will react with what? Our amine, because amine is alkaline. So our final product will be OH, COOH, but NH3Cl. You might say, why, like if this is a neutralization reaction, we know in neutralization reaction what happens? Water is generated. But here the condition is in such that this ammonia has a tendency to gain H plus. Okay, that's what that's what alkali does. If let's say sodium hydroxide is present, okay, what happens? We add HCl. What do they do? They do NaCl is happening. Who is the alkali here? This OH, isn't it? That means OH minus like gained a H plus, forming what? H2O, isn't it? So addition, like gaining of hydrogen is known as, is the characteristic of what? An alkali. Similarly here, when we have H2, it has a tendency, like nitrogen has a like lone pair of lone pair of electron. So it has a tendency to gain a H plus. If it gains a H plus, then what did it do? It fulfilled the requirement for alkali. But there was this Cl minus like floating around. So since this is a positive charge and since this is a negative charge, they combine together forming a salt. Okay. So for amine or for for amine, ammonia, the conditions are a bit different, but still it's a neutralization reaction because ammonia itself is a not very strong base. It's sort of a weak base. Now, when we added bromine, what happened? See, carboxylic acid does not react with bromine water. Amine does not. Amine does not. Only thing reacts with bromine water is what? Phenol, because it is a characteristic. It helps to identify the phenol, isn't it? Remember? So it reacts on the 2, 4, and 6th position of our phenol. So phenol is in the first group, and let's say this is our structure so far, NH2. Then bromine will be added to which position? 2nd, 4th, and 6th. Okay, let's add it on the 4th group. But since 6th group, 2nd group is added, 4th group is filled, so no more, no group will be added in the 4th group, but we can have it on the 6th position. So this is our Br. Okay, so that's our, this is what color? White precipitate, remember? White PPT. So this is our reaction for the product we found. Now let's come to our in detail, a thorough topic of protein. So we'll be doing some visualization and a bit in-depth study of protein. So protein. So what are the structure of protein? So structure of protein. Let's say the first structure is the primary structure. Okay, primary. Then the second one, you can also say this as degree 1, first degree. Then we have secondary. That could also be mentioned as say secondary, degree 2, second degree. And finally we have what? Tertiary. It's degree 3, you could say. So these are the 3 structure of protein. Now let's define each of them. First one, which is primary. A primary structure is the sequence where the amino acids is in the polypeptide chain. So when we will be giving some, let's say we'll be giving some examples, you'll be that will make sense more, but for now just go with the flow. So it is, let's say, primary structure is just normal sequence of amino acids, sequence of amino acids, okay, in or polypeptide chain, polypeptide chain. Okay, what is the secondary protein then? Now this is a regular structure arrangement of the polypeptide chain that results from hydrogen bonding between the CO and the NH group in peptide bond region of the chain. Now, what does that mean? Let me again say the definition. So it is saying here's a regular structure, normal regular structure, okay, regular structure and or structural arrangement of the polypeptide chain. So which results hydrogen bond between whom? The carbon oxygen double bond. Leaving this like before sign, like this sign, this means that there is some other components there. Just writing that it is a continuation of the bond, and NH similar here. That means continuation of the bond where NH is there. This group, between these groups in the same peptide bond region. Now, what do we have in the peptide bond? In a peptide bond, we have CONH, isn't it? We have this bond. That means if this is the chain, and here we have some other chain, let's say here we have like let's say there are some like the other amino acids part, okay, and there's that CONH. This goes on, okay. I'm just for simplicity, I'm just writing just the peptide part, okay. Like this goes on. Now, if this is one single chain, another chain is, let's say, this is the chain, CO, and let's say we have what? Just a minute. Let's say, yeah, let's say we have the other portions. Let's say this is our NH, and it goes like this. And let's say this is our CO, NH, and here we have our NH, CO. Okay, this is the portion. Like this is how it goes. Okay, now what happens? See, this nitrogen's hydrogen. This nitrogen's hydrogen. Okay, this and this carbon's oxygen, they tend to form the hydrogen bond in between them. Here they tend to form hydrogen bond between them. Now this is the peptide linkage, isn't it? The peptide region of the bond, the peptide region. And between these two peptide region, like this hydrogen bond is formed. Okay, between like this two peptide region, the hydrogen bond tends to form. That's what they are saying. The secondary protein is, the structure of secondary protein is. So it's more like it will have more of a structure of like this. You can say, let's say there's a spiral of protein, okay, like the chain, the polypeptide chain, okay, this is the chain. Now in one of the chain, let's say we have, or we had, let's say one of the chain we had, let's say there's this carbon and let's say the nitrogen bonded in this chain. Like any of the chain, I'm just drawing that specific portions chain structure. And similarly, let's say this was the other portion where there was this carbon oxygen bond and nitrogen and hydrogen, let's say. Okay, so this was the one, like it goes on like it went like this. Okay, let's say wait, it doesn't make sense. Just give me a second to explain it. Yeah, so this goes like this, and let's say we have this. If we go in the other way, so we will be having, yeah, it's fine. Yeah, it's fine. So it was correct. So yeah, so let's say there is carbon and oxygen. So in between this carbon and oxygen, like the upper hydrogen and the lower oxygen, they tend to form bond. Like same chain, in the same chain, this hydrogen bond can also be formed. Okay, so this is the single same chain was there, and the hydrogen bond was between whom? The nitrogen of, or the hydrogen of the same chain from the nitrogen, like the peptide linkage, and the oxygen from the same linkage. Let me detail it a bit further. Let's say, let me draw it in larger way. Let's say this is the spiral, okay? Then what would have happened? Let's say this is our carbon, oxygen, nitrogen, hydrogen, and there was that carbon, oxygen, and nitrogen, hydrogen, okay? It went like that, and in between them, this hydrogen linkage was formed, okay? So in the same spiral or same chain, and this is known as actually alpha Helios model. Yeah, this is known as LPH alpha Heli. Wait, what is the name? I can't even pronounce. Alpha. Is it? Just let me actually search it up because I'm not sure what I've written. Alpha helix, yeah, alpha helix structure, isn't it? Yeah, it's alpha helix structure. So it is a rod-like structure whose inner section is formed by the tightly coiled main chain with the side chains extending outward helical array. So yeah, I've written there that means alpha helical structure or alpha helical model. The alpha helix structure takes advantage of the hydrogen bond between carbon and nitrogen, CO and NH group in the main chain to stabilize. Okay, so yeah, that's what you can also see in the internet. It's written there. So that's what it's alpha helix structure. Now, moving on to the third part, which is our tertiary structure. What does this tertiary structure happen? Like contains? So it is actually the structure, like, so this is actually overall folding of the polypeptide chain. That is the result of the interaction between the amino acid of the side chains. Now, what does that mean? That means, like, so far we did what? In the secondary protein, we did what? The regions of the polypeptide, isn't it? Polypeptide, that means in the main chain that happened. Now let's say this was the chain peptide groups. These are our peptide groups. These are, let's say, let me draw it in the better way. Wait, yeah. Let's say we have, what structure do we have in protein? Take a look at what structures. Okay, let's say we have that was given result of interaction between the amino acid side chains. Okay, so let's say our amino acid is given. This was our peptide linkage, let's say, and CH, and that's that R group. Let's say in place of R group we have the CH2, let's say COOH, okay, and the other portion continues. This is the, like, one of the amino acids, okay. And when bond forms, what happens? When bond is formed, like, this portion disappears, that portion disappears, and like the hand sort of extends, isn't it? Like, becomes hands-free. Now let's say there we have another portion, another amino acids, okay. So let's say that, like, upside down. Here we have, let's say, in place of that, let's have CH2 4 and NH2, okay. And we have the same thing, just like the mirror image of each other, but in like in the other way we are just showing. Okay, that's how it goes. Now these are like, that's one of the chain, that's another chain, okay, that's another molecule or another chain, you can say. In between the chain we have now the side chains. These are the side chains. Now this side chain may have some sort of interaction between them. Let's say here, if COOH and NH2 is there, then what sort of bond will form? They will directly form CONH. Another peptide linkage could be formed there, or they can also form like the hydrogen bond there as well. So in between the side chain reactions or bonds can form. That's known as actually what? Our tertiary structure. Got it? Now, moving back to our examples, let's say, when we will be doing some example sets, so it will be like much more vivid to you, because different component will have different sort of interaction. If let's say only alkyl groups are present in between, then only van der Waals forces of attraction, because that time no like hydrogen bonds component were there. Hydrogen bond is formed between what? Oxygen and hydrogen of two different like bond of two different molecules. So in place of CH2, let's say only CH3 we have, another CH3 we have. What sort of bond will they form? They will interact with each other in such a way that they will have van der Waals force of attraction, intermolecular forces of attraction. But if they have, let's say, this carboxylic acid and amine group, then they will actually interchange, like form a peptide linkage could be formed there. Then there is the possibility to form hydrogen bond. If there is this alcohol, let's say, and this NH2, then simply hydrogen bond will be formed there. Okay, so we'll be studying more like about the types of bond in more detail. But let's see another example of our secondary alcohol, like a secondary protein. So for second degree, let's say our structure is given carbon, hydrogen, R. This is the peptide linkage. Say this is our peptide part. Okay, and here we have, let's say, N. This is the hydrogen. Like it follows a structure, certain structure. Let's say this is the structure. Like it repeats. I'm just drawing the main chain. Let's say in a zigzag pattern, I'm drawing the main chain. So this is a peptide linkage. That's another peptide linkage. Okay. And we have CH, R, N, H, and it goes on. Okay. Now let's say similarly, we have another molecule present, like towards the bottom. Let's say this is our hydrogen. Then there is carbon. Carbon is bonded with, let's say, hydrogen, and like another alkyl group, the side chain group. Then we have, let's say, this carbon or the oxygen. We have this nitrogen, hydrogen, again C, H, R, like this like the same chain, let's say. Okay. And we have H, R, and finally we have, let's say, carbon, and it goes on. Okay. Now these are the two chains. Okay. Now see what can happen is this is the nitrogen, hydrogen, and this is the carbon, oxygen. They will have this bond between them. They will have this hydrogen bond between them. Okay. They will form or have this hydrogen bond between them. So these are the hydrogen bonds they are talking about in the secondary structure. This structure, which I've just drawn, is known as the beta plated sheet. So beta sign in physics, you have seen the beta sign is this. So beta plated, PLEATED, plated sheet. Let me search in the internet, like if my spelling is correct as well. BATA PLEATED. Yes, it's correct. So the rest of the parts we will be having in our second part. Okay, second part of the video.